Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by Techstrong Learning. My name is Cody and welcome back. We have an exciting panel ahead, but before we get things started, I have just a couple of housekeeping notes to review. First of all, we are recording today's session. So if you happen to miss any of our discussion, if you'd like to rewatch at a later time, or of course, if you'd like to share with your team, you will be receiving an email with a link to access the recording on demand shortly after we conclude this live session today. Now, if you'd like to engage with us, there are a few options to do so. The first and the easiest option is the chat tab. So you'll find that chat tab on the right side of your screen. And when you do find it, let us know from where in the world you are joining us. If you have any specific questions, we want you to send those questions into the Q&A tab. Sending your questions to the Q&A helps us keep track of all of our questions that come in so they don't get lost in the chat. And we'd love to answer as many of these as we can, so be sure to send them in to that Q&A section just to make sure that we do actually see them. Additionally, before we close things out today, I am giving away 2 $25 Amazon gift cards, so be sure to stick around to see if you're one of our lucky winners. So our topic is infrastructure as code. And I'm joined today by Tiffany Wang, Solutions Architect at Weaveworks. And moderating this conversation is Mike Vizard, Chief Content Officer here at Techstrong Group. So Tiffany, thank you so much for joining us. Mike, I'm gonna kick it on over to you now.
All right, well, thanks, Cody. Tiffany, good to see you.
Good to see you too. Thanks for having me.
You know, I would love to start out with a little perspective. I think we can all agree that infrastructure as code tools, especially things like Terraform, are fairly pervasive. They've been around and everybody's been using them for a number of years. But what is your sense of the overall maturity of how we use those things? Because all too often, in my experience, it's kind of individual developers are using them with, shall we say, mixed success.
Yeah, I think that's a very fair question to start out with. And I would agree, infrastructure as code has been around a long time, and Terraform, I would say, is the most popular and most widely adopted. I think that it depends on the organization and the company that you work in terms of how infrastructure as code is used and to what degree it is used. Certainly, it's possible for infrastructure to be managed by perhaps individuals, but as the scale of the company sort of grows and as the companies themselves are more mature in understanding the importance of having sort of platform teams that are responsible for things like cluster provisioning and infrastructure provisioning, that's where infrastructure as code becomes hugely important and widely used across the engineering org, possibly owned and maintained by platform teams, but certainly impacting all the way down to application developers that require that infrastructure to run. And I would say I would argue that, again, this might depend on the company, but it is mature, where there are, not only is there infrastructure as code, but more sophisticated implementations that include things like policy as code. So I think maybe a shorter response is it depends on the scale of the company and also how much is invested and how much teams are incentivized to ensure infrastructure as code is used, adheres to all of the regulatory requirements if there are any, and yeah, it could certainly be. There's a wide spectrum, but I would say on the most part, at least companies that I've worked in and worked for, I would argue it's quite mature.
I would agree, but it does seem we have folks attending who are all across the spectrum, and we have our first question. And since I'm trying to encourage as much interactive behavior as I can here, that first question just wants somebody to kind of sort this a little bit. But how does using infrastructure as code tools compare to the more traditional manual infrastructure management practices that we've used in the past? Because I think there are still some folks out there that are quote unquote doing it the old school, perhaps hard way.
Yeah, and if done poorly, if infrastructure as code could certainly repeat all of those same sort of pitfalls with the added level of complexity of having to learn, additional, potentially a new language, right? With Terraform, you have to understand HCL. There's a huge learning curve there. But I would say that and I would say that, part of the reason why we look to infrastructure as code to begin with are to address things like reproducibility, and also to get the inherent assurances, you might say, that you get with source control management. If you're defining your infrastructure as code in Git, you have the inherent audit trail, who made what change, when, and why. And although there is, arguably that high learning curve to understand the significance of the different, I want to say modules, I would say, and that's maybe specific to Terraform, but ultimately, once you have ironed out, reusable components that you can use to provision, infrastructure for different clusters, it does ultimately reduce the time it takes to provision and deliver that infrastructure, while also reducing risk for change, because you're not a human who's prone to error, clicking buttons in a console, or firing off CLI commands. There should be a stringent review process that you make your change, open a PR to get somebody to review the changes you're intending to make. So any change that you seek to make to your system has that review and oversight from other team members, possibly security teams if there is a security sort of org at your company. And these things lend themselves to increasing developer velocity as well. Whereas, manual provisioning of certain infrastructure might have had lead time and needed, prioritization in a queue. This is now something that, if allowed by your org, application developers might have agency over. And so, that in conjunction with, Git being the lowest common denominator across your engineering organization, I think that these are reasons why many companies today are sort of mandating that you use our infrastructure as code as a general best practice.
Right. There is clearly a lot of developers using this in the name of productivity, shall we say. It makes it easier for them to spin things up, and they're now waiting for some centralized IT team. But I think one of the dirty little secrets about all of this is that it leads to a lot of misconfigurations, and those misconfigurations are the things that the bad guys are trying to exploit, and they have scanners going looking for open ports and whatever it is. How do we kind of approach that in a way that allows us to remain productive? But it feels like we need maybe some sort of guardrails, because, well, it's too much of a good thing. So how do we kind of bring some quote unquote adult supervision here?
Yeah, that's definitely a great point. And I think I might have mentioned briefly introducing policy as code, so that any changes that you're looking to make to your infrastructure, pass through policy verifications, and or in conjunction with security team who are the experts, reviewing as potentially even required reviewers on sensitive infrastructure components. But with things like policy as code, you can define and specify or flag and reject things like IAM policies that might be overly permissioned, ports that are open that shouldn't be. If you have if your volumes need to be encrypted because you're under regulatory requirements to do so, etc., as one means of automated checks. But I would say, having the human element of PR review to ensure that the changes you make are acceptable, or the changes that you seek to make are acceptable and comply with any restrictions that your industry might require, or even as your the policy that you have for defining the infrastructure are met, that would ensure that that would prevent developers from being able to create infrastructure that is open to the wide internet. And I would say that there's always going to be a risk when humans are involved, right? We're fallible, and it's human to make mistakes. And I would say that that's something that end segregation is sort of important to keep in mind as well, especially and segregating workloads, and perhaps you do have a dev environment that is locked down from the rest of your infrastructure, and clusters serving traffic, and giving developers a space to have an environment for them to test their changes out in before promoting through to higher environments. And I think those are maybe a handful of
I guess
options.
I can't help but wonder if maybe the expectations of what developers can effectively handle on their own is too high. We hear a lot about cognitive load, and we've been talking about shifting left for a long time now. But it seems to me that developers wind up spending an inordinate amount of time managing environments and infrastructure rather than writing code. So have we gone a little too far left and we need to kind of swing the pendulum back a little bit? What's your thoughts here?
Yeah, I would say, and sorry, my answer is going to vary depending on sort of the scale and perhaps even the size of the engineering department. It's easy. It's maybe easy to say, oh, this is the reason why a cloud platform tooling team is needed, so that they can do the heavy lifting when it comes to defining the bulk of the infrastructure as code, components that might be used by application developers, so that it lessens that cognitive overhead for them to have to know the ins and outs of something like Terraform, something like Crossplane, name your infrastructure as code tool. And being able to abstract as much of that away from developers, I would say, is something that the tools exist for, but certainly needs to be shaped for your company's specific needs.
All right. And to your point, not everybody on the development team is equally savvy. So you might have some newbies out there who are more likely to make a mistake than somebody who's experienced. But then again, people who are experienced have bad habits, and so you never know exactly what's going to come out of the other end of this anyway. We have a question from somebody who's kind of alluding to this issue, so let's just jump into it. But is this becoming a bigger issue and a more challenging issue because more organizations are starting to use multiple clouds, and each of those clouds are somewhat different, and I need that layer of abstraction you were talking about? But are we entering some sort of new phase here when it comes to infrastructure as code?
Yeah, that is something that comes up quite a bit in conversation, I would say. In terms of targeting multi-clouds, I think that this might be one of the reasons why Terraform is such an attractive option for managing infrastructure as code, because there are certainly differences between the providers, the major cloud providers, the cloud platform providers, but having, and there is the caveat here that you do need to understand Terraform and HCL to be able to write modules against the providers that you are targeting. And I would say that while there are public modules available, those need to be understood, top to bottom by your teams if they're using them. And it's often it might cost more time and effort upfront, but in the long term, having modules that are written specifically against your requirements to be used by either whoever owns those components is just sort of a recommendation. But I guess it depends on the tool, but being able to support multiple clouds is something that I'm seeing many tools having support for. So it's abstracting your infrastructure and defining it as code is important. And it's when you're deciding which tool to use, it's important that, if you're going to be targeting multiple clouds, you take that into consideration.
Mm-hmm. You mentioned platform engineering, and we've seen a lot of people talking about that lately. And from my perspective, it's essentially finding a way to manage DevOps workflows at a higher level of scale. And a lot of that starts with templates and creating all that. How hard is it to create those templates? Can I get them from somebody on the web and just download them, or am I writing them for my own specific environments? And who writes them, and how do I distribute these things in a way that other people will find them and use them? Because at least in my experience, I can give developers all the templates in the world they want, and half the time they never see them.
Yeah. So this is kind of near and dear to my heart, and I believe that platform teams are really meant to facilitate and improve the developer experience of the application developers. And I would argue that it's sort of, the responsibility of the platform team to not only either put together templates, if there are some that suit the requirements that are open source, to provide examples of how those are used, and to share that with the wider application developer audience. And I would say that platform engineers should always be endeavoring to abstract as much away as needed from application developers in order to help to drive the velocity of each underlying application dev team, right? Like you were saying, Mike, there is a lot to know. And when you're saying that, our applications your applications need to be deployed to Kubernetes, there's a lot of overhead there. And so by having a platform team that one can provide tooling that makes it easy for application developers to, either reuse components and where they only have to specify, certain, requirements for their application, whether that's infrastructure that they need for their application to run. And I can go, I can talk about GitOps for a long time as well, but sort of abstracting the delivery piece to the Kubernetes target and simplifying that as much as possible. I think those are certainly areas that platform engineering teams should help drive.
Well, it's not clear to me that everybody listening to this knows even what GitOps is. So take a stab at defining it, because from my perspective, at the risk of a gross oversimplification, it's unifying the management of infrastructure as code with the rest of the DevOps workflow. But tell me what you guys are defining that as, and where are we seeing it?
Yeah, so I would say that GitOps is a methodology where you declaratively define your desired state, and you have an agent that continuously reconciles what you've defined as desired state against your running cluster. And maybe an example might help illustrate this a little more clearly, where, say in order for your application to run, you need a deployment, you need a service, you need a service account, and you need some RBAC resources to run. Those can, once you've defined those, tools like Flux are able to read contents from your Git repository and make sure those are translated and deployed to your cluster. Where, if you were to manually change something, whether by accident or for nefarious reasons, Flux would detect that change in the running cluster and reconcile it back to what you've defined as your desired state. So I guess one of the other important things to note is with infrastructure as code and with GitOps, developers should not have a need to have write privileges against their clusters or to the cloud platform provider APIs either. It should and nothing should be done manually, right? You have the basically any change that you're looking to make to your system should be introduced via PR.
Mm-hmm. Is this something I'm primarily seeing in cloud native and Kubernetes environments? And I ask the question because one of the issues with software delivery in general has always been that every platform is a snowflake, and Kubernetes provides kind of, a unified set of APIs, or at least reduces the variance. So is GitOps really tied around cloud native, or can we also apply this to more of our traditional monolithic environments? How broadly does GitOps work?
Yeah, I would say GitOps as a concept is applicable far beyond cloud native and Kubernetes. And I should have added a caveat up front. My expertise lies in Kubernetes, so that's where you'll hear most of my answers coming from. So yeah, I think that it's, when you take a step back and you look at GitOps and you understand and you have the experience of working on deploying an application, and it turns out that there's only one person who knew how to deploy it from their specific machine, and they're on holiday, and then the system kind of can crumble quickly. Whereas if you are stringent on ensuring all of your desired state, whether that's for your infrastructure, whether that's for your application workloads, is defined in Git, and you have a common and consistent method of, review and ultimately delivery, automated in the case of GitOps, but you have a lot of benefits to reap, and you short circuit some of the tribulations that you might otherwise have.
Mm-hmm. Do you think organizations are also struggling with, at least when I visit some of them, there might be 4 or 5 different DevOps teams and they've all done something somewhat different from each other, and some of that is redundant and some people are better at it than others. So as part of this exercise with Gitops and platform engineering, just can we settle down on what's the best practice for a particular use case and go with that one versus having 6 flavors of the same use case?
Yeah, absolutely. There's, there can be, no, it's not there can be, there are definitely so many tools and so many different ways of using those tools to achieve similar outcomes. And yeah, absolutely. If you have the luxury of having 4 different DevOps teams and each each has their own, defined workflow. Imagine those 4 teams coming together and working on a, sort of common tooling that can be used by all and understood by all, right? So if an engineer changes from one team to another, it's not, 6 more weeks of onboarding and getting up to speed on how they do things. Having a common tool set and common workflow is hugely beneficial.
Mm-hmm. Is Terraform essentially now a de facto standard? Because we are hearing about other infrastructure as code tools there. I think Amazon has something, and there's a bunch of other ones that are out there. And I can't help but wonder if, I think of Terraform as kind of an abstraction. Now I need another abstraction to manage all my abstractions. So, what's your sense of how this is going to play out?
Yeah, I feel, the fact that there is, ready, a lot of support surrounding and use of Terraform, and the fact that, in my experience, they're pretty quick to react when cloud platform providers, provide new functionalities. Those get baked in quite quickly. I would tend to agree that Terraform is, perhaps the most widely used tool out there, but there are definitely newer tools coming on the scene. We were chatting briefly before, but there's tools like Crossplane where you define your infrastructure components as Kubernetes resources, and that sort of dovetails back into not only using infrastructure as code, but having GitOps go hand in hand with the delivery of your infrastructure components. And I would say that maybe even taking a step back, tools like Terraform are really great at allowing you to define your IC as kind of a declarative state machine. And what might be lacking there is sort of a reconciliation loop on the infrastructure that you're provisioning. So things like if you were to, run your Terraform plan, happy with that, run your Terraform apply, you're happy with that, and the changes are made and your infrastructure is provisioned, being able to go back and, if there is a developer that has write privileges and misuses them, there isn't a default sort of way to make sure that what you've defined in your infrastructure as code is the only configuration that you have running in your environments. So extensions to Terraform, things like the Terraform controller, if you've heard of that, help to make sure that what you've defined is what you've defined does not diverge from what is actually configured for your infrastructure.
Okay. A lot of folks that I've talked to like the idea of Gitops, but they find it hard. It seems like it's difficult for them to wrap their heads around it, or maybe it's just a fundamental change in culture. But is there an easy button for Gitops? I mean, how do I kind of get from where I am today to something we call Gitops? And might I get there on purpose, or is it going to be more accidental?
Yeah, I think that it's, I guess maybe it's easiest to see the benefits if you've lived a life without GitOps and then you have GitOps and then you realize, oh, what a blessing this is. But if you are starting from a position of you're new to Kubernetes, you're new to cloud native tooling, then what do you do? And in those scenarios, and if it's if you're working in a small company with a handful of devs, I think that it's important that at least one has understanding of Kubernetes and cloud native tooling, things like Helm, right? That can help abstract a few of the layers that application devs might need to understand. So, you can do a lot by setting up a Helm chart and just, having application devs focus on, the business logic, the code that comprises an application, which culminates in an image. So, it's possible that their responsibilities might end after CI and after their image has been created. And then the act of having, defining your workloads in a way that Flux can pick up and reconcile might be as simple as defining a Helm release, specifying a Helm chart, and passing in the values that you need.
All right. I think we've used the phrase Flux a couple of times now, but let's just define what Flux is for folks, because I'm not sure that they all understand that either.
Yeah, so Flux is a CNCF project. It has graduated, which was very exciting. And it's basically, its runtime is comprised of a set of Kubernetes controllers, where each controller is responsible for a certain task. For example, there's the Flux source controller, and that's responsible for reaching out and reading contents from, say, a Git repository, a Helm repository, or an OCI repository, or S3 bucket, what have you. And that's how Flux understands, where it should retrieve, the resource it will eventually reconcile. Then we have the customized controller and the Helm controller, and those are the reconciler controllers. So you'll specify, certain paths or certain charts that Flux. You'll specify, say, a certain path. So within your Git repository, you can point to a specific location in that repository, and Flux can apply the contents that it finds there. And that gives you a lot of flexibility in, defining multiple different places that Flux reads and reconciles resources from, as an example of what Flux does. And maybe I can take a step back and explain that, a Kubernetes controller is kind of like an operator where you have a custom resource definition that is an extension of the Kubernetes API that is understood and acted upon by the controller to affect change within your cluster.
All right. That sounded like a central nervous system for GitOps, but.
That's right.
All right. Way to simplify that. All right. We've gotten this far. It's 1:34. We're 34 minutes in, and I have not mentioned the magic phrase artificial intelligence. So here we go. What do you think the impact of AI is going to be on GitOps and the way we think about provisioning infrastructure and DevOps in general, because we have been using with mixed success predictive analytics, and now we're moving into more generative AI. So I see that benefits developers like crazy. They can write more code than ever of suspicious quality, but how will that kind of work its way through on the back end where the software engineers live?
Yeah, and you just made me laugh because mileage definitely can vary here. And I think that AI in general has a huge potential to improve and automate, infrastructure as code, GitOps workflows. But there are certainly caveats in this space. Their AI systems can often, have hallucinations where they'll be adamant that this is the correct answer when in fact that answer is completely wrong. But companies like Weaveworks have invested in training models against private data and using methods like reinforcement learning from human feedback, RLHF, for higher accuracy and efficacy. I think that one of the challenges is that while there is a huge breadth of publicly accessible information, in order to make sure that, the results produced by AI are usable and, can be used with some level of confidence, there's a lot of fine tuning that's needed. And there are some, certainly very exciting developments in this space. And I think there will be some announcements coming soon, including announcements for tooling that leverages this RLHF in addition to low-rank adaptation of large models or LoRa for fine-tuning against private data sets that are powered by Gitops and Flux. And I guess in a more general, thinking of where AI can be applied, maybe eventually, is in the generation of IC for existing infrastructure, tools to help people write it. So to, lower the learning curve that you would otherwise have, whether that's Terraform, whether that's for even GitOps workflows, and then also to help detect, security vulnerabilities by evaluation before your changes are applied and deployed. And, we were touching on multi-cloud and how there are certainly differences amongst even the major cloud providers, right? It's not, hopefully it's not in the far off distant future that translating your infrastructure as code from one cloud platform provider to another is something that is feasible there too with AI.
I think people just want two simple things. One, in the short term, just explain to me what changed from yesterday. That things were working fine yesterday and now they're not working fine. Just explain to me what happened there. And then the longer term, I think people just want to be able to come in the office and say, hey, tell me the 3 things that are likely to get me fired today and what I should be doing about it. So that's a little more complicated question, but hopefully we get to that someday. I kind of want to touch on some questions from the audience. And the first one is, if you're only using one cloud platform, would you go to the trouble of learning Terraform when each of the cloud providers gives you their own tools? So Azure has one, Amazon has one. Is it worth it? Or I'm not sure I know of anybody who can really enforce using one cloud provider, but we'll see where we go from there. But what's your thoughts?
Yeah, I would, given that question, I would ask a question in response and say, are you sure that you will only ever target one cloud platform provider? Because if the answer is yes for now, but maybe not in the future, you're right. Cloud providers do offer, tooling of their own, but it might be code debt that you're writing from the start. And I think that's something important to consider when you're making the decision. If you know for a fact that you will never be in any other cloud but Azure in this case, then I would say it depends on the skill set and preferences of your engineering team and who will be responsible for using Bicep. And I'm sorry, I'm not familiar with Bicep myself, but certainly I would say having some form of IC is better than not. And keep in mind, if it's a possibility that you might target multiple clouds in the future, I would have that play a role in making a decision on what infrastructure as code tool to use.
All right. And I'm going to circle back to another question. I know that you guys are pretty tied up with Terraform, but are there other multi-platform IAC tools that you're thinking about supporting or looking at, or is anything that leaps out at you? One of our attendees wants to know, what else is out there that they should be at least considering?
Yeah, I would say have a look at Crossplane, especially if your developer community is more well versed in or has familiarity with YAML. And then, I suppose, I think that Ansible has support for some of the different cloud providers. And let me think. There is the options that are cloud platform provider specific, of course, but yeah, I would say, let me think. Are any coming to mind for you, Mike?
Well, I guess the only one that comes to mind for me immediately, I know there's a handful out there, but Pulumi is running around.
Oh, Pulumi. Yes, of course. How could I forget?
There you go. All right. Let me ask you this question. We talked a lot about the technical challenges, but the cultural issues are as significant, maybe even more significant. How do I kind of get from where I am today culturally to get everybody on board to this whole thing? I mean, am I just going to take everybody, lock them in a room till somebody sees sense, or is there kind of some way to go after this in a way that gets everybody to buy in, not just from the top down, but from the bottom up?
Yeah, I certainly agree with you. Sometimes the greatest challenge might not be technical, and I would say to mitigate the challenge is to reduce as much of the friction as you can from, and to be empathetic towards, the consumers of your tooling, if you're on a platform team, or, if you are making decisions, thou shalt use infrastructure as code, for example, to not just have that be a mandate, but to provide, copious documentation for your developers, make it easy for them to pick up and, use in a dev environment to become familiar with it. And I think that it's, humans, I think most humans by nature are sort of resistant to change, but when they can see how much of an impact that has on their productivity once they get the hang of it, there are metrics that can be measured as well. So I would say being open and providing copious documentation, and having pairing sessions. If you're a platform team engineer and you are creating great tooling or tooling that you think is great that solves so many problems for application developers, I think it's important to gather as much feedback as you can to make your application developers feel heard, and really take their feedback on board and incorporate functionality to tooling you're providing, or if there are, common questions that crop up, document it, and have a sense of community around it, as opposed to sort of dictating that what teams have to do. At least in my experience, that's been useful.
I think if you want a conversation to go badly, all you have to do is start a sentence with "you need" or "thou shalt," right?
Right. Definitely would not recommend those approaches.
Right. You mentioned community. So are there places you would point people towards to join communities and engage with other folks who might be like-minded?
Yeah. If you, I myself am part of a few different Slacks. There's the CNCF Slack. If you are, and I apologize, these recommendations might be very Kubernetes focused, but I think Kubernetes has, widespread adoption, and this is where my recommendations might stem from. But the CNCF is a great place, and specifically the community Slack is great to join. You'll find a whole bunch of channels that might be focused on topics you're interested in or that you have questions for. Weaveworks has a community Slack for Weave users. Anybody can join, and I'll make sure that we send out some links to these different groups that I'm mentioning after today's call. And Kubernetes has its own Slack as well as some areas. I would say that GitHub for open source projects for tools that you might be using is also a great place. Whether it's the issues or the discussions, maintainers, in my experience, are pretty active in those places as well. So being able to talk to the people who are building the tools that you're using can be really, really helpful.
All right. Communities are awesome because they're less expensive than psychiatrists and less damaging to your health than a bar, right? All right. Question. What is ultimately your best advice to folks for how to proceed? I mean, you've been at this for a little while. What do you know now that you wish you knew when you first started this whole adventure?
Yeah, I would say if you are new to things like IEC and possibly to Gitops, new to cloud native and Kubernetes, I would start fresh, as in set up a cluster, define your infrastructure components as code, and start slowly migrating your workloads over. It's difficult to have, one foot in a world where you're, trying to manage things manually and trying to manage those same resources or trying to define those resources declaratively and via infrastructure as code. It can be difficult to understand that, hey, this is what I've defined, but I don't know why this has changed all of a sudden. And it turns out somebody else in your team has write privileges and was testing something of their own. So having good communication across teams that are, sharing multi-tenant clusters is important. And I would say, barring dev environments, possibly, you really shouldn't have write privileges. And if you shouldn't have write privileges by default. Things can change in exigent circumstances where you need to have break glass scenarios, where you need to have methods for, break glass scenarios, but you typically, should reap the benefits and keep manual intervention out of the picture as much as possible. it makes your life a lot easier in the long run.
All right, we have one more question from the audience that I'd love to get to, but somebody wants to know what your thoughts are on reverse engineering an existing IAC installation. They're suggesting tools like Firefly and Spacelift. I'm not familiar with either one of them. In my personal experience, reverse engineering is painful, but maybe you have a different perspective.
Oh, sorry. I was reading another question as you were mentioning that question. I'm sorry.
No worries. But yeah, so, coming back to what are your thoughts on reverse engineering? Is this something you think people should do, recommend? Is it unavoidable? What's the best way to think about this?
Yeah, that's a great question. I guess it can be it's certainly useful to understand how to reverse engineer, but hopefully if it's something produced by somebody on your team, on a different team, you can communicate with them as well. And I apologize, I'm not familiar with Firefly or Spacelift myself. But, as with any other kind of, troubleshooting efforts, maybe time boxing before you reach out for help, because it can take, especially if you're in a scenario where, where write privileges are available and somebody did something manually and it's not somewhere that you can see this is exactly what was used to deploy this exact, workload in my cluster, or this exact this exact definition was used to configure my infrastructure. You can very quickly tear your hair out to understand what changes were made. So,
all right, I think do so at your own peril. You might want to think about just re-provisioning it all together, because chances are that whatever you're reverse engineering is deeply flawed to begin with. So think twice, and what did they say? Look before you leap, kind of thing. All right. We have one other comment from our audience talking about, well, it's more of a statement than anything else, and it's just a reminder that I think we need to make sure we do not overlook the fundamentals of distributed enterprise computing. It's all about development life cycles and data orchestration at the end of the day. Tiffany, you agree?
Yes. I think that it's really important to understand how we got to where we are today. And I think that you can get quite far without understanding the fundamentals, but when push comes to shove and you need to have, deep, whether that's networking understanding or, SDLC and, SDLC and understanding importance of, adhering to contracts for things like data motion and data orchestration. It definitely is important, and can really come in handy in a pinch, let's say.
There you go.
And
I think that's a particularly important comment these days in the age of AI, where there's going to be a tendency to say, oh, I'll just rely on the machines. But I guarantee you the machines are going to do you wrong one day. So you need to know how it works. All right. Tiffany, enjoyed the chat. Thank you all for watching. I'm going to kick it back to Cody, who's going to take us out and do those all-important gift cards.
Awesome. Well, Tiffany and Mike, thank you both for joining us today. Really learned a lot from this conversation, and I hope our audience did too. So for our audience, just a reminder that we have been recording our discussion today. So if you happen to miss any of it, or you just want to rewatch, you will be receiving an email with a link to access that recording on demand. You can also find it living on the DevOps website at devops.com/webinars. And be sure to look in the on-demand section where it will be waiting for you. The two winners of our $25 Amazon gift card drawing are Timothy M. and Srihari R. So to our two winners, congratulations. Keep your eye on your email inbox. You'll be receiving an email from me here shortly If you don't happen to see that email, check your spam folder just in case it happens to be filtered. I'd like to thank Tiffany once again for joining us, and to everyone here, thank you so much for joining us as well. At the top of the chat, there is a link to fill out our survey, and we'd love to hear your feedback today. But either way, we hope to see everyone at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect. Thanks again, everyone.
Okay.
Thanks, everybody.